All right, video 2, we're going to get through problems 7 through 12, and this is on the exam 3 prep. It looks like problem 7 is a word problem on direct variation, so let's go ahead and read, and we'll remind ourselves what direct variation is here shortly. If this will load. It says, on a given planet, the weight of an object varies directly, so there's the key word, varies directly with the mass of the object. Suppose that an object whose mass is 7 kilograms weighs 14 newtons. Find the weight of the object whose mass is 9 kilograms. Okay, let's go ahead and open up OneNote here. Now, when it says varies directly, right, we have two options, directly and indirectly. This one is directly. Let's go ahead and grab a new page here. And so the equation that we use for directly, let's write this without a highlighter. We'll say directly, we're looking for y equals kx. Right, this is our equation. We'll go across indirectly in a second, but what this is saying is one of the variables go up, so does the other. Right, so you'll notice in this problem, right, we're talking about 7 kilograms and 14 newtons, right? So the way we want to write this is 14 newtons is equal to K times the 7 kilograms. And now for whatever reason, you decided to flip it and do the opposite way, you would still get the same answer, which is what we're going to get. Right, so if you wrote 7 on the left side, 14 on the right side, it does not matter. Now in this case, right, if we solve for K, this is our first step. We'll just write solve for K. It would make sense that if I divide both sides by 7, right, I'm going to get K is equal to 2, right? So our equation here is y is equal to 2x. And now it gives us another piece of information. It says, well, I believe the number is 9, but we'll go back just in case. Right, it says, find the weight of an object whose mass is 9 kilograms. And so all we're going to do is plug in 9. Right, in this case, 9 is our x. So y is equal to 2 times 9. Or in other words, we get 18, and it doesn't matter, but 18 newtons. Right, so this is a word problem which varies directly. Right, now before we move to the next one, since we're already on the whiteboard here, the next one's going to say indirectly. And so instead of y equals kx, we're just going to have y is equal to k divided by x. But it's the same process, right? And this is going to be indirectly. So let's pull up the problem, which I believe is next here. Let's see, we can get rid of this. We just answered that, right? There we go. And I'm correct, inverse variation, right? So we have the equation written out, but it's going to be exactly the same. It says Boyle's law says the volume of gas varies inversely or indirectly. When the volume of a certain gas is 4 liters, the pressure is 370 kilopascals. What is the volume when the pressure is 296? Okay, so our numbers here are 4 and 370. So let's go ahead and set this up. Where are we? 4 and 370, right? So, and again, it doesn't really matter as long as you, right, keep it consistent. So as of right now, this is what we have. And so if we want to solve for K, it would make sense that we need to multiply both sides by 4 to get our K value. 4 times 370, 1200 plus 280, so 1480 is our K value. And so now when we write our new equation with our K value that we solved for, we have 1480 over x. Right, so it always comes down to the first step, solving for that unknown K. Once we solve for K, right, we can rewrite our equation, which is what we did. And now we can go back to the problem, and it says, what is the volume when the pressure is 296? right? So make sure we're putting the 296 where we put the 370. And what I mean by that, so let's go back, 296, right? Notice I had 370 as my y, right? So when I put the 296 in, it is also the y value, right? That's what I mean by don't get them mixed up. And now we need to solve for x, right? And so what we do is we're going to move x to the other side to get 296x is equal to 1480, or in other words, right, we need to divide 1480 by 296. Now I don't have that off the top of my head, so 1480 divided by 296. And again, feel free to pause the video, slow it down, whatever you need to do. 1480 divided by 296. Hopefully it gives us a calculator. Yeah, it does. Make sure to utilize this. 1480 divided by 296 equals, oh, 5. Maybe I could have done that one in my head. Let's see if that is, do we do it right? Yep, 5 it is. Okay, we're closing out. I know we're moving fast. I still do want to make the last video, which is going to be 13 through 18. So I'm hoping to have enough time. That was 7 and 8 and 9. We're going to just do this one here. I don't think we'll need the whiteboard. It says, so we need to think about what it's saying. It says, write an equation that expresses the following relationship. P varies directly with the square of d. All right, so directly means we have that y equals kx, but instead of using the y and the x now, they're using a p and the d. So it says p varies directly, so p is equal to the square of d, right? And it's the constant here as well, right? So k times d squared. Let's see if it likes that. Yeah. So p varies directly with the square of d. Let's try another one just so we have, now we have an inverse, right? So it says d varies inversely, so we're just going to write d equals, and we know that this means we would normally have k divided by x, so let's just put the k divided by the cube of w, so w cubed. Good. Okay. All right, so let's see. let's look at one more. This is going to be the same, right? Just so you have, oh, I guess this is a little bit different. So it says u varies directly, so we have k times something, right? With p, so k times p, and inversely, so now we're going to divide by the square of d. All right, so that was good. We got 3 different. Just as we go, good to just type it in. U varies directly with p, so k times p, but inversely, so we're going to divide by the square of d. Awesome. Okay, moving forward. The nice horizontal line test. Shouldn't be too bad. Right, horizontal line test. Remember, so it's going to say, it's going to ask if the function is one-to-one, but the way that we test one-to-one is a horizontal line test, meaning if you can draw a line horizontally and hit 2 points, it is not one-to-one. So in this case, right, this is one-to-one because if I draw a horizontal line anywhere, I'll only hit at most 1 point. Graph 2, right, notice if I draw a line through y equals -2, I hit 2 points, so this is no. Same thing, graph 3 here is not one-to-one. Horizontal line test does not work for an upside down parabola. Let's see, graph 4. Graph 4 looks okay, right? These are all operating on different y values, I think. So I think this one's fine. And it does give partial credit. For instance, you got one of these wrong. Graph 6 is going to be no, right? And graph 7, yes, right? Horizontal line test works. Horizontal line test for graph 6 does not work. Did I get them? I got them. I feel like there's 6 different variations there, so that should be okay. Inverse functions. Okay, we'll go back to the whiteboard for this, right? I know we had quite a few questions on this. So it says, and it does say it's going to be a rational one, so that gives it away immediately. right? So it says the one-to-one function is defined below. F of x is 7x divided by 8x minus 5, right? 8x minus 5. 7x divided by 8x minus 5. Okay, now the first thing I want to do before I get started is I'm going to find the domain of this. Notice that we have domain issues for rational functions when I take my denominator, let's just write it below, 8x minus 5, and set it equal to 0, right? And then we're going to go ahead and solve. We can't divide by 0, so whatever x value I get here is going to be causing an issue in the domain that I want to skip over. 8x is equal to 5. X is equal to 5/8. And so that means our domain here is negative infinity all the way to positive 5/8. We're going to want to skip over that. And we have 5/8 to infinity. Okay, and we're going to save this for later in case we forgot why we need this. This will be helpful later on. So this is kind of step one. Find the domain of the original function. Now, if we want to find f inverse, right, that's our next step here, or probably the whole problem. Let's see, there we go. We're going to switch, right, let's rewrite this, but using a y placeholder, just a little bit easier to deal with. And now we're going to switch our x's and our y's. So everywhere we see a y, we'll write an x. Everywhere we see an x, we'll write a y. And now we want to solve for y. Now with these rational functions, they all follow a similar pattern. We're going to have to move that 8y minus 5 to the other side. And we're going to need to distribute that in with the x here in a second. So let's go ahead and distribute that x. Okay, let's say it's equal to 7y, and I need to get all the y's to one side, so I'm going to move the 8xy to the other side. Again, as long as you get them on one side, it doesn't matter how you do it. I know there's two possibilities, right? Could have moved everything to one side, vice versa. Now that we have all the y's on one side, we can factor one out. And so we're left with 7 minus 8x, right, when we factor out a y. And now we can finally solve for y by moving the 7 minus 8x to the other side. And thus we have found our f inverse. And what's nice about rational functions, which sometimes isn't true about other functions we're working with, is it's very nice and easy to solve for the domain here, right? We do the same thing we did above with our other rational function. We take our denominator and we set it equal to 0. And then we go about the same process, right? Negative 8x is equal to negative 7, which means x is equal to 7 over 8, right? This will cause an issue in our denominator. We can't be equal to 0 in our denominator. That's why we set it equal to 0. And so our domain here is negative infinity all the way to 7/8, and then we'll jump to the other side and we'll go to positive infinity. We'll highlight this. Right, so we have our f inverse, this is part of the question. We have our domain, this is the part of the question. Now the other thing that it asks for in this question is, well, what's the range of this, or what are the y values that we can get out of this? Now the reason why I wrote down the original domain from the function is because the domain of the original function, which we already found, is the range of our inverse function, right? So this is also the range of the inverse. And so there's no more work for us to do if we've already done this to start. We'll just go write it for the range. What was it? 5/8, right? Was the issue? 5/8. And so our range here is negative infinity to 5/8. Union 5/8 to infinity, right? So in essence, what you're doing is you're finding the domain of the inverse, which is this one, and you're also finding the domain of the original function, which is the range of the inverse. So that gives you both of them. And again, feel free, I know I'm going through these fast, but feel free to slow down the video, rewatch if you need to. I am giving away the fact that it will be a rational function. That's nice. That is the one that you would see in your exam prep. Let's go ahead, we'll get rid of that. And lastly, translating a graph. I don't think we're going to need the whiteboard. It's already given us the graph, right? And remember, this is a vertical, right? We can either have a vertical or a horizontal shift. This is a vertical shift in which we're moving down 2. So let's just grab right here. We know that the exponential crosses the y-axis at 1, and so we're just going to move this down 2 spots. 1 more, and boom. Let's see if we get a nice, uh-oh, what did I do? Oh, I didn't see the horizontal shift. Good, I've made the mistake for you. Okay, so I did part of it. I did the vertical shift, right? The -2. The horizontal shift, it says x minus 1, right? This is our horizontal shift. And remember, for horizontal shift, it's kind of the opposite of what you think would happen. It would make sense a -1, you would move to the left 1, but actually, we're going to move to the right by 1. Let's try it again. There we go, good. Let's do another one since I messed up that one. Okay, so I'm paying attention now. Now we have a vertical shift. I always deal with the vertical shift first. It's kind of easier. Of a +3, so I'm at 1 right here, so I'm going to go up to 4. So far, so good. And now this says a +4, so it's the opposite of what you would think would happen. So I'm going to move to the left by 4. 1, 2, 3, 4. Awesome. Okay, so that gets you through problem 12. Probably tomorrow morning. I know hopefully you guys are doing this and you're just using these videos as resources to check when you get stuck on specific problems. So tomorrow morning I'll upload 13 through 18 and then they should all be up there. All right, I'll see you guys tomorrow.